Hello guys, welcome back to all. In this video, I'm going to explain about what is an octet rule. So we know that the scientists called Cossel and Lewis in the year 1916, the both scientists developed an important theory of chemical combination between the atoms. So that is known as electronic theory of chemical bonding, right? So in the year 1916, the scientists both Cossel and Lewis, they both are developed the theory is called electronic theory of chemical bonding. So what is this theory is explaining means, according to this theory, every atom is tries to get the octet configuration. Why the every atom tries to get the octet configuration means to getting the stability purpose. So to getting the stability purpose, every atom prefer to have 8 electrons in their valence shell or the outermost shell, right? Valence shell or the outermost shell or the last shell, whatever it may be. By how the every atom tries to get the 8 electrons? By 3 ways. Either by losing or electrons, or by gaining electrons, or by sharing of electrons. So, in order to get the octet configuration in their valence shell, every atom is tries to get the 8 electrons by losing electron or by gaining electron or by sharing electron. Already we discussed in the topic chemical bonding what is an ionic bond or what is the covalent bond. So in the ionic bond or covalent bond, every atom is trying to get the octet configuration. Octet configuration means containing 8 electrons in the valence shell to get the stability. So every atom is trying to get the octet configuration. So this is what about the octet rule generally. But now this octet rule is not universal, which means of course it is helpful or useful to explaining the stability concept in many atoms or molecules. But this octet rule is also having some drawbacks or what you call the limitations. It is not explaining some properties regarding this octet rule. Now let us see what are the limitations of the octet rule. Of course, it is not universal, which means it is not acceptable in everywhere. Of course, it is useful in some extent to explaining the stability concept, but the structure of most of the organic compounds and it applies mainly in elements in the second period of the periodic table. So, there are some exceptions are there. What are those exceptions? Let us see. So, the first exception is that the incomplete octet of the central atom. So this is the first exception or what you call the drawback or the limitation. So incomplete octet in the central atom. So for example, take BF3 or LaCl, beryllium hydride, or BCl3 or many other BH3, AlCl3 and so on, beryllium chloride. So these elements are called incomplete octet. In these elements the central atom, so here if in this case the boron, beryllium, boron, lithium, boron, aluminum and beryllium. So these central atoms may not containing the octet configuration. I will explain with one example. If you see, for example, in case of beryllium chloride. So in the first example, beryllium chloride. So we know that the beryllium chloride, how it forms. So we know that the beryllium electronic configuration is 1s2, 2s2. It contains 4 electrons. Is it okay? So in the outermost shell it contains 2 electrons. So this is the beryllium atom. So it contains 2 electrons. If you see in case of chlorine, so chlorine contains 1s2, 2s2, 2p6, 3s2, 3p5 configuration. So now in this case, in the outermost shell, the chlorine atom will contains only 7 electrons. Is it okay? So to get the octet configuration, it requires one more electron here. So for stability purpose, it requires one more electron. So that is why this chlorine atom is forming bond with the beryllium atom. So like this chlorine atom will contain 7 electrons in their outermost shell. So total number of 6 and 7. In the same way, the second chlorine atom will also having 6 and 7 electrons. So like this, in between the two beryllium and chloride, there exists a single covalent bond. So like this, beryllium chloride will form. Of course, beryllium chloride is a stable compound, stable molecule. But here, if you observe here, this chlorine atom having 2, 4, 6, 8. So chlorine atom having octet configuration. In this case also chlorine having 2, 4, 6, 8. So this chlorine atom is also containing 8 electrons. But if you observe here, this beryllium atom only contains 4 electrons, which means here this central atom is incomplete octet configuration, which means it is not containing 8 electrons. It contains only 4 electrons, which means it is incomplete octet. But according to octet configuration, every atom should have 8 electrons to getting the stability. But here in this case, the beryllium contain only 4 electrons, but it attains stability. So beryllium chloride molecule having more stable. Not only in case of beryllium chloride. If you observe here, already we discussed, in case of beryllium hydrate and lithium chloride, boron trichloride, AlCl3, so BH3, in every molecule, the central atom may not containing the complete octet configuration. In case of BCl3, the boron will contain 6 electrons in the octet, in their outermost shell, but there exists a stability, which means the BCl3 is a stable molecule. But in that case, the boron may not having 8 electrons, but it is stable. How it is possible? So such type of limitations, which means such exceptions are there in the octet rule. This octet rule is not giving any clarity regarding that one. So that is the first limitation. If you observe here, in lithium chloride, the lithium having only one valence electron. In case of beryllium, it contains 2 electrons. Boron, it contains 3 electrons. But they are stable. How it possible means there is no clarity. So this is the first limitation. What is the first limitation in the octet rule? The incomplete octet in the central atom. So this is the first limitation. And now let us see the second limitation. The second limitation is that odd electron molecules. What is this odd electron molecule? Which means, see, in some molecules with an odd number of electrons will present in their outermost shell. Take for example nitric oxide, and another example is nitrogen dioxide. In the first case, if you observe here, this nitrogen atom will have 7 electrons. So 1s2, 2s2, 2p3 configuration, which means this nitrogen atom will have 8 electrons in their valence shell. So this nitrogen atom will have 5 electrons in their valence shell. So 2, 4 and 5. In case of oxygen, this oxygen atomic number is 8. It contains 1s2, 2s2, 2p4 configuration, which means it contains 6 electrons in their valence shell, like this, 2, 4, 6. So it requires 1 electron. It requires 3 electrons to get the octet configuration, whereas this oxygen atom requires 2 electrons to get the octet configuration. So now this oxygen is forming bond with this nitrogen atom like this. So if you observe here, in this case, here there are two bonds, double bonds will be formed between the nitric oxide. So if you observe here, there exists a double bond. In this case, this oxygen atom is stable by sharing the 2 electrons. So total number of 2, 4, 6, 8. So the oxygen atom is getting 8 electrons. So this is stable. But if you observe in the case of nitrogen here, this nitrogen contains only 2, 4, 6 and 7. Which means here odd electron is there. Only single electron will be there. Like this. Which means here in nitric oxide N double bond O, the nitrogen atom will have odd electron. But in practical, the nitric oxide will be stable. But it is not explained why, how it will stable. So this is what the second limitation in the octet rule. In the same way, if you observe in case of NO2, so nitrogen dioxide, if you observe here this nitrogen dioxide, we know that the nitrogen atom having 5 electrons. So 1, 2, 4, 5 electrons like this. And take 2 oxygen atoms. So this oxygen atom is containing 2, 4 and 6 like this. And another oxygen atom is there. This contains 2, 4 and 6. So here this oxygen atom is stable by making single bond with this nitrogen atom. And this oxygen atom is also getting stable by sharing these 4 electrons. So total number of oxygen atom 2, 4, 6, 8 electrons. Here in this case also oxygen atom having 2, 4, 6 and 8 electrons. But if you observe here, this nitrogen atom will have, here the oxygen atom will getting minus value and plus value here. So one odd electron will be present in this case. So like this NO2 also example for the odd electron molecule. So this is the second limitation. It is not explained by the octet rule. And let us see the third limitation. The third limitation is the expanded octet. What is the expanded octet means? Which means the central atom may have more than 8 electrons. For example, take PF5 and SF6, IF7 and H2SO4 and many compounds. So in practical, PCl5 and ClF3, so all these compounds are stable, which means they are having stability. But if you observe there, in case of, let us see in case of PF5, how the PF5 will be formed, let us see. So we know that the phosphorus atom having the configuration 1s2 2s2 2p6 and 3s2 3p3. So here in the outermost shell it contains 5 electrons, right? So the phosphorus atom, this is a phosphorus atom. It contains 1, 2, 3, 4, 5 electrons. In case of fluorine atom, so fluorine already we know that it contains 1s2 2s2 2p6, 3s2 3p5. So it requires only 1 electron to get the octet configuration. So that is why total number of 5 fluorine atoms are combined with this phosphorus atom like this. So if you observe here in this case, there exists total number of 5 covalent bonds in PF5. So here if you observe, the central atom may contains 2, 4, 6, 8, 10 electrons. which means it contains more than 8 electrons. So this is called expanded octet. This is called expanded octet. Not only in case of PF5, if you observe in SF6, the central atom sulfur may have, it will also forming SF6 means like this, which means here 2, 4, 6, 8, 10, 12, which means the central atom may contains 12 electrons. If you observe in H2SO4, here the sulfur will contains 12 electrons in their formation. So here in case of H2SO4, the sulfur molecule will form like this, H2SO4. So every oxygen molecule will have 2 lone pairs like this. It forms 2 hydrogens. So this is the formation of H2SO4. In this case, if you observe here, the total number of 2, 4, 6, 8, 10 and 12. So total number of 12 electrons will be present in the central atom, H2SO4. This is the formation of H2SO4. So here also it is containing 12 electrons, but it is stable. H2SO4 is a stable compound. So this is what the third limitation of expanded octet, which means in the first case we are incomplete octet. We discussed in case of BCl3, beryllium chloride, BF3. So these compounds are called electron deficient compounds, electron deficient molecules. Why? Because here the beryllium or boron may contains less electrons, which means the beryllium and boron may contains either 4 electrons or 6 electrons, which means they are called electron deficient molecules. They are not containing octet configuration. But here also the sulfur and phosphorus, it is also not containing the octet configuration, but it contains more than 8 electrons. So that is why it is called expanded octet. So these 3 are the main limitations of the octet rule. And there is a fourth limitation is also there. What is the fourth limitation? Let us see. Mainly this octet rule is not explaining the shapes of the molecules. So this is one of the most important one. This octet rule is just explaining the how the molecule will form. The stability concept is explaining, but it is not explaining what is the shape of the molecule and how the shape of the molecule exists. So this is one of the limitation in the octet rule. And the second limitation is that it does not explain the relative stability of the molecule or the energy of the molecule. So this is also one of the reason. Energy of the molecule is not explained by this rule. The third point is that, so octet rule means this octet rule is based on the noble gas electronic configuration. Is it clear or not? So noble gases means we know that hydrogen, helium, neon, argon, krypton, xenon and radon. So these zero group elements are called inert gases or noble gases, which means they contains, except helium, the remaining all elements contains 8 electrons in their valence shell. So that is why they are most stable and they need not to participate in any chemical reaction. So this octet rule is based upon the chemical inertness of noble gases. But some gases, for example xenon and krypton, will combine with oxygen and fluorine to form a number of compounds like XCF2 and KRF2 and XCOF2, etc. So generally the xenon is a noble gas and krypton is also noble gas. They need not to participate in any chemical reaction because already they are stable. But how these compounds will form, how this molecule will exist in nature. So this is also not explained by the octet rule. This is one of the most important limitations. So these are all about the limitations of the octet rule. So this is today's class. If you have any doubt, you can ask through the comment section. And if you want more videos like this, please share and subscribe my channel. Thank you all of you.